DIY spot welders often use high-powered components that can be a bit frightening, given the potential for dangerous malfunctions. In this video you can see the process of making a spot welding machine locally. Generally, copper alloy electrodes are used, but depending on the welded metal, the electrodes can also be made from tungsten, molybdenum and other materials. Resistance spot welding is a fascinating topic to both welders as well as researchers. It is a type of resistance welding technique, which itself falls under the pressure welding category. Traditionally, spot welding is an integral part of automotive manufacturing. You might have seen large robots swiftly moving around and welding the chassis of a car. This process is actually spot welding. In recent times, another simple application of spot welding is lithium-ion battery packs. If you are learning to be a welder or looking for more information on spot welding, then you have come to the right place. What is spot welding? When we say resistance welding, we usually mean resistance spot welding, RSW, or simply spot welding. It is the most popular and common type of resistance welding. Using spot welding, you can weld metal sheets with thicknesses up to 25 mm each. The automotive industry is a major implementer of spot welding. You can see YouTube videos of assembly plants where large robotic spot welders weld the chassis of the car. In fact, you can have an average of 4,500 to 5,000 spot weld joints in a regular-sized car's chassis. A typical spot welding system consists of three parts. They are the main structure, the electrical system, and the force-forward/pressure application system. The frame or structure of a spot welding system provides strength and rigidity to the whole system. It also has the mechanism to hold and move the electrodes. The electrical system consists of a transformer, step-down transformer, capacitor, current regulator, timing circuit, and control circuit. Finally, we have the mechanical system that is responsible to hold the metal sheets and also to apply force through electrodes during the welding process. There are a couple of ways to produce this force. Medium and large spot welding systems use a pneumatic, compressed air, subsystem. Smaller spot welding units are using high-quality servo motors. Apart from these two, we also have hydraulic and spring-loaded mechanisms to produce the clamping force. Another important part of the spot welding system is the electrodes. They are responsible for two functions. The first one is to clamp the workpieces with force and apply pressure on them. Second, they carry the high amperage and low voltage current that produces heat and essentially welds the pieces together. Principle of operation. The working of a spot welding unit is very simple. It involves the precise application of electric current and mechanical force with the necessary extent and period. The electrodes that hold the workpieces together also carry the current. First, the passage of electric current at the contact point of electrodes and metals causes a significant amount of heat that will melt the metal. Next, the two pieces are held under pressure for the metal to fuse and cool off. Finally, you can release the pressure from electrodes on the sheets. Depending on the shape of the tip of the electrode, the weld will be an elliptical-shaped nugget or any other shape. As it is a time-sensitive process, we can divide the operation of a typical spot weld cycle into 4 timed steps. They are squeeze time, weld time, hold time, off time. Overlap the two pieces of sheet metal and place them between the electrodes. Now, it is time to hold these workpieces with the electrodes and apply pressure on them. The amount of time required for the electrodes to build or raise the force and properly clamp the metals is squeeze time. It is also the time between the first application of force on the workpieces and just before applying the electric current. After the buildup of proper force, i.e., after squeeze time, we are now ready to apply the current. The time during which the weld current passes from the electrodes to the workpieces is the weld time. By the end of the weld time, the contact point will be in a molten state. After the weld time, the current shuts off, but the electrodes continue to apply pressure on the workpieces for a certain amount of time, which is the hold time. During this time, we are essentially allowing the metal to cool down and at the same time apply force. This stage will solidify the molten metal and create the weld nuggets. After the hold time, the electrodes release the workpieces from their grip and be ready to weld the next spot. This time is the off time. Parameters of spot welding. We have already seen the timing-related parameters of a spot welding process. But are there any other important variables or parameters? Yes. We have a couple of important parameters. Let us take a quick look at the same. Welding cycle. It is the 4 steps we saw earlier, consists of squeeze time, weld time, hold time, and off time. The welding cycle varies from material to material as it is associated with physical and mechanical properties. Welding current. It is the electric current that flows through the electrodes and then to the surface of the workpieces. If you remember the equation of the thermal energy we mentioned before, this energy is proportional to the square of the current. So, applying the right amount of current is crucial. In most cases, the current of high amperage and low voltage. If you take a 1 mm thick uncoated steel sheet, for example, it needs anywhere between 7 kA to 10 kA of current. This can be either AC or DC. Clamping force, pressure. The electrode force or the clamping force is another important parameter. It is the force that the electrodes exert on the workpieces. If the force is too little, this will increase contact resistance and result in poor weld quality. On the other hand, if the clamping force is too high, it will reduce the area or the weld, which in turn reduces the strength of the weld. Electrode area. The area of the electrode determines the current density of the spot welding system, which is the amount of current per unit area. The diameter of the electrode is proportional to the thickness of the metal. Total resistance. If you remember the thermal energy equation, we mentioned the amount of heat generated is directly proportional to the resistance across the weld, which is the total resistance. When we say total resistance, it is the sum of individual resistances such as contact resistance between the electrode and the metal, the resistance through the individual metal, and also the contact resistance between the metals. Spot welding electrodes. The electrodes of the spot welding system play an important role. They are responsible to clamp the workpieces together and also apply the high amperage electric current to weld the metals. Copper is a popular choice of electrode material due to their superior electrical conductivity, thermal conductivity, and strength. Copper alloys with internal water cooling are commonly used electrodes for spot welding. Apart from copper alloys, we can also use tungsten and molybdenum. The next important factor regarding electrodes is their shape. Some commonly available shapes of electrodes are pointed, flat, offset, dome, etc. You have to choose a proper shape depending on the type of material you are welding and also its thickness. Types of spot welding machines. Spot welding machines are available in several configurations. One of the simplest spot welding machines consists of a spring-loaded rocker arm with foot pedals. This is completely a manual machine where the operator has to do all the heavy lifting. The operator places the workpieces between the electrodes and aligns them properly. Then, he/she depresses a foot pedal, which activates the electrode rocker arm mechanism. Some models have a simple air compressor to control the rocker arms. These spot welding machines are inexpensive and suitable for small shops. Next, we have the press-type spot welding machines. In this, The lower electrode arm usually stays stable while a pneumatic system controls the movement of the upper electrode arm. These machines provide very stable operation with precise electrode alignment. Slightly larger machines use a hydraulic system to control the electrode. Both these machines are good for small productions. If you are looking for a large production that operates at very high speed, then you should look at robotic spot welder. These types of spot welders are very common in industries, especially automotive assembly plants. They are high speed, precise, and accurate, and the best thing is you can automate the entire process. The clamping force is provided by a pneumatic system or servo motors. For a high production rate, you can also get multi-spot welders. Instead of one weld, you can perform more than 20 spot weld joints at a time. But the limitation of such systems is they are suitable for relatively straight pieces of sheet metals. Advantages of spot welding. Spot welding is quick, suitable for high quantity production. It is faster than arc welding and brazing. The operator or technician needs very little training to operate the machine. You can easily automate the welding process with spot welding machines. No deformation of the metal as the area of the weld is pretty small and the thermal energy is confined to this area. Resistance spot welding is a fast, reliable, and accurate welding technique often used to weld sheet metals. The automotive assembly industry is one of the largest implementers of spot welding using robotic spot welders.